Hi, in this video we're going to change the subject of a formula where we've got some brackets involved. Now what does it mean to make x the subject of the formula? It means to get the x on its own on one side of the equation. Now I'm going to use a few tricks in this method here to make things a bit quicker, but I do explore how to do it in full in previous videos. Now if you've got these brackets, one thing you could do is to expand out those brackets. So if I do that, I do the y multiplied by the a, which is ya, but we should actually say ay because we put it in alphabetical order. And we do the y times the minus 2x, which is minus 2xy, and that is equal to b. Now, do you remember from a previous video that if the x is inside a term that's being subtracted from something, we can use something called the Swapsy trick. Now let's remind ourselves of the Swapsy trick. If, for example, we had 10 minus 3 is equal to 7, how could we reorder some of these numbers to get another subtraction which is still true? Well, we could say that 10 minus 7 is equal to 3. 10 minus 3 is 7 and 10 minus 7 is 3. So it seems that we can swap the thing that's being subtracted and the result of the subtraction, so the 3 and the 7. So in this particular case, we can swap this thing that's being subtracted here and the result of the subtraction. And if we do that, then we get ay minus b is equal to 2xy. And now that's good because now the x is a bit more freed up. It's not being subtracted from something anymore. Now, again, we want to get the x on its own. We think what's happening around it and undo those things around it. Now, the x has been multiplied by the 2 and by the y. So to get rid of the times by 2y, we divide both sides by 2y. And if we do that, we get ay minus b all over 2y. And then on the right-hand side, we just left with the x. And that's the final answer, because x is now on its own on one side of the equation. And we typically put the subject on the left-hand side of the formula, so we could write x equals ay minus b over 2y, like that. And that is the final answer. Now, another way we could deal with this is to not expand out the brackets and instead do appropriate division. So let's just write this again. Y a minus 2x equals b. Y a minus 2x is equal to b. So instead of expanding the brackets, note that the a minus 2x is being multiplied by y. So the last thing that's done here in this expression is multiplying by the y. So we're going to divide both sides by y to get rid of that y on front of the brackets. And if we do that, the left-hand side, the times by y disappears, leaving a minus 2x. And on the right-hand side, if we divide it by y, we get b over y. If you want to divide something by an expression, you just put it over it in a fraction. Now, again, we could use that Swapsy trick because, look, x is in a term that's being subtracted from something. So we can swap the thing that's being subtracted and the result of the subtraction. So we get a minus b over y equals 2x. And then finally, the x has been multiplied by 2. So to get rid of the times by 2, we divide both sides by 2. And if we do that, we get a minus b over y all over 2 is equal to x. And this, believe it or not, is actually equivalent to that. So a way we could tidy it up is I don't like this fraction within a fraction. So if that happens, you can multiply top and bottom of the outer fraction by the denominator of the inner fraction. So I'm going to multiply top and bottom, the numerator and denominator, by y. And if we do that, the top becomes, well, the a times y is ay, and then minus, and then the b over y, the times by y cancels out the over y, just leaving the b, so we get minus b, and then the 2 at the bottom, the denominator times by y, you get that. And now, hopefully, this is the same as the expression we had before. And you can see, indeed, it is ay minus b over 2y, ay minus b over 2y, and we're done.